Hello from AJ Educational Academy. This is the next video which we are doing series of important questions from 10th class mathematics, second chapter sets. So these are the this is the final video for, related to sets wherein we are going to solve some more questions which are very important for exam perspective, right? So here we have a set. A is a set wherein x is a variable such that x is a factor of 12 and x is a factor of 30 in the set B. Two sets are there. We have to find the relation between n of A, n of B, n of A union B and n of A intersection B. For such questions, in order to find the relation between these questions, we have a formula n of A union B. N of A union B is equal to n of A plus n of B minus n of A intersection B. This is the formula. N of A union B is equal to n of A plus n of B minus n of A intersection B. What is this n? N is nothing but the number of terms. Cardinality number we call that. So n is nothing but the number of terms. N of A in that sense number of terms in A. N of B number of terms in B. N of A union B. First you have to do A union B, then find the number of terms in it. N of A intersection B. First find A intersection B, then find number of terms in it. Substitute in this formula, verify the relation. LHS should be equal to RHS. So one good thing about this question is by the end of the question you will be you will get to know that did you solve that correctly or not. So that's how it is. So first of all, before going into A and B, first of all we have to extract A and B here. A, if this is given in the set builder form, we have to write in the roster form, then find union, intersection and number of terms. So that is what we are going to do here. So A is a factor of 12. Factors of 12. What are the factors of 12? We discussed in the previous class. 1, 2, 3, 4, 6, 12. Set builder form to roster form. Next B, factors of 30. Factors of 30. 1, 2, 3, 4, 5, 6 and then 10 and then 15 and then 30. So basically what are the factors? Factors are the numbers in which the given number is divisible. So those are factors or divisor we can call that, right? So from the set builder form we have made into roster form. In the formula n of A should be there, n of B should be there, n of A union B and intersection. So we have A and we have B. We'll find n of A and n of B. I'm writing n of A here only. N of A in the sense number of terms in A. How many terms are there? 1, 2, 3, 4, 5, 6. 6 terms are there. N of A is 6. N of B. N of B in the sense number of terms in B. How many terms are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 terms are there. N of A, N of B is done. N of A union B, N of A intersection B is required. So before that we have to find A union B and A intersection B. A union B. A union B is equal to, let me write A first. A is 1, 2, 3, 4, 6, 12. Union B. What is B? 1, 2, 3, 5, 6, 10, 15, 30. Right. A union B. In union what do? We write the common terms only once, and apart from the common terms whatsoever is there in the first set that has to be included, and also whatsoever is there in the second set that also has to be included. 1 is there in both the sets, I'll write only once. 2 is there in both the sets, I'll write only once. 3 is there in both the sets, I'll write only once. 4 is here but it's not there, still I have to write. 5, 6, 7 is not there, 8 is not there, 9 directly 10, 12, 15, 30. So this is union, A union B. Also we will find n of A union B, number of terms in A union B. How many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many terms? 10 terms. N of A union B is also completed. A intersection B. First we will find A intersection B. What is A? 1, 2, 3, 4, 6, 12. Intersection B. 1, 2, 3, 5, 6, 10, 15, 30. Intersection. Intersection in the sense we'll write only the common terms. Intersection in the sense we'll write only the terms which are common. 1, 2, 3, 1, 2, 3, 6. Is that it? Right. This is A intersection B. We'll also write number of terms in A intersection B. How many terms are there? 4 terms are there. right? So whatsoever is required for the formula, we have all of that. N of A is there, N of B is there, N of A union B, N of A intersection B. We'll substitute in the formula. First of all, let us take LHS part. In the LHS, N of A union B, which is nothing but how much? N of A union B is 10, right? RHS. In RHS, what is there? N of A plus N of B minus N of A intersection B. N of A, how much is, what's the value of N of A? N of A is 6 plus N of B 8 minus N of A intersection B 4. 6 plus 8 is 14. 14 minus 4. 14 minus 4 how much? 10. So, end of this problem, we can easily conclude that did we solve it correctly or not. If the answer is not correct, which means you must have done some or the other mistake while converting or doing this basic operation. So, please be very peculiar over there, hence proof. In the next question, here we have A is a set wherein x is a variable such that x is a multiple of 4 and it is less than or equal to 50. Next, B is a set wherein x is a variable such that x is equal to 6n, n is less than 10 and n belongs to natural numbers. So, we have to show that n of A minus B, number of terms in A minus B is equal to n of A, number of terms in A minus number of terms in A intersection B. That is what we have to show. So, first of all, we have to extract A and B. This is the set builder form. From the set builder form, we have to convert into roster form and find A and B set, followed by A minus B we have to do and find the number of terms in it. A intersection B we have to do and find number of terms in it. A if we find, we can directly write the number of terms in A. So, that's what it is. Alright. Multiple of 4 less than or equal to 50. Multiple of 4 in the sense 4 table clearly. 4 from 4 to 40. After 40 less than or equal to 50 in the sense 44 and 48 as well till 48. Next multiple is 52, but he said that less than or equal to 50. So, we have to write from 4 to 48. 4 to 48. 4 comma 8 comma 12 16 20 24 28 32 36 40 44 48. Here, so set builder form to roster form, multiple of 4 less than or equal to 50. So, 52 is also multiple, but the limit multiple I already told multiple will extend till infinite. There has to be certain limit. So, that's why he has given limit 50. So, we least multiple less than 50 is 48. How many terms are there? We will write it here only. Number of terms in A. Number of terms in A. How many terms are there? 12. Because 4 times is 40. 10 terms. 11, 12. So, overall n of A is 12. Next, B. In order to find the value of B, there is one function given. X is equal to, what is it? X is equal to 6n and the value of n is less than 10. Less than 10 in the sense from 1 to 9. From 1 to 9. N is equal to 1, 2, 3, so on up to 9. For all the value of n, we have to write the value of x. Look at this, n is less than 10. Less than 10 in the sense till 9 we have to take. What does this less than 10 represent? It is giving us the limit of n. N should be written till 9. N belongs to capital N. Capital N in the sense natural number which starts from 1. Natural number starts from 1. Whole number starts from 0. So, n is equal to capital N. Capital N in the sense natural numbers. We have to start from 1 and we have to write till 9. From 1 to 9. For all the value of 1 to 9, what is the value of x? That is what we have to find. If n is equal to 1, which implies x is equal to 6 into 1. 6 1 is 6. Next, if n is equal to 2, which implies x is equal to 6 into 2. 6 2's 12. If n is equal to 3, which implies x is equal to 6 into 3. 6 3 is 18. If n is equal to 4. If n is equal to 4, x is equal to 6 into 4, which is equal to 24. If n is equal to 5, x is equal to 6 into 5. 6 5 is 30. Next, if n is equal to 6, x is equal to 6 into 6. 6 6 36. Next, if n is equal to 7, x is equal to 6 into 7. 6 7's 42. If n is equal to 8, x is equal to 6 into 8. 6 8s 48. Next. Till 9 we have to take, no? Yet one more term. If n is equal to 9, x is equal to 6 into 9. 6 9s 54. So here we have the set B. We shouldn't take 10 less than 10 it all. Less than or equal to 10 in the sense we have to include 10 as well. But less than 10 is till 9. Less than 10 is till 9. All the values till 9. What are those? 6 to 54. 6, 12, 18, 24, 30, 36, 42, 48 and 54. So this is the set B. Number of terms in B. Is it there? Number of terms in B? It is not required. We have to do A minus B, n of A minus B, n of A intersection B. N of A we already got. N of A is already there, which is 12. We have to find A minus B. First A minus B we have to do and find number of terms in it. Number of terms in A minus B. We have to do A intersection B and then find number of terms in A intersection B. First let us find A minus B. A minus B is equal to, while doing minus we have to write both the sets. What is A? 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48 minus B. 6, 12, 18, 24, 30, 36, 42, 48, 54. That's all right. While doing minus, what do? We cancel out the common terms from the first set and whatsoever is remained in the first set, that is what we write. So what are the common terms? We'll start from 12. 12 is there. Next 24, 36, 48. So if these terms are cancelled, what is remained? 4, 8, 16, 20, 28, 32, 40, 44. This is A minus B. Number of terms in A minus B. Number of terms in A minus B. How many terms are there? 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 terms are there in A minus B. Right. Number of terms in A minus B we have. Number of terms in A we have. All we have to do now is A intersection. First A intersection B will do. Then find the number of terms in it. A is equal to A again 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48. Intersection B 6, 12, 18, 24, 30, 36, 42, 48. Is that it? 54. Number of terms in B. A intersection B this is. Right. Common terms. What are the common terms? The one which we cancelled over there. You can 12, 24, 36, 48. So these are the common terms in both the sets. This is A intersection B. We have to calculate number of terms in A intersection B. How many terms are there? 4 terms are there. Right. Shall we substitute in the formula? Right. In the formula LHS part. LHS, what is it? N of A minus B. N of A minus B. How many terms are there in A minus B? 8 terms are there. RHS is also supposed to be 8. N of A minus N of A intersection B. N of A is 12. N of A is 12 minus A intersection B. Where is A intersection B? Yeah, okay. 12 minus 4, which is nothing but 8. Clear? LHS equal to RHS, hence proof. First, you have to convert from set builder form to roster form. Apply basic mathematics over there and convert the given sets to set builder to roster and then find the relation. If the relation like that it is given already, all you have to do is substitute it over there. Otherwise, write the formula and do it like how we did for the previous sum. Copy this down. Here we have another question in front of us. A is a set wherein x is a variable such that x is equal to n square and value of n is between minus 3 less than n less than 5, which means n is greater than minus 3, greater than minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, less than 5. So minus 3 and 5 are not included. If it is minus 3 less than or equal to n, which means we'll include minus 3, less than or equal to 5, which means we'll include 5 as well. It is not equal to, in the sense minus 3 and 5 are not supposed to be included. Greater than minus 3, minus 2, lesser than 5, 4. So from minus 2 to 4 we have to take, and n belongs to whole numbers. N belongs to whole numbers. Whole number in the sense, where do whole numbers start from? 0. So in this case we have to also neglect minus 2 and minus 1. Actually, based on this we can set the value of n as minus 2, minus 1, 0, 1, 2, 3, 4. However, based on this value we have to neglect the value of minus 2 and minus 1, because it starts from whole number, which is 0. Clear? We'll substitute the value, find the value of find the set A, set B, and here we are asked to find n of B minus A. Number of terms in B minus A should be equal to number of terms in B minus number of terms in A intersection B. Let us extract A and B first. A and B given for set A, given x is equal to n square, and the value of n is 0. Value of n starts from 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Actually, it should start from minus 3. Minus 3 and minus 1 should also be included based on this value. However, if we go even further, it said that it belongs to W, whole numbers. Whole number in the sense, those numbers starts from 0. Clear? So, let us substitute the values. If n is equal to 0, if n is equal to 0, x is equal to 0 square, which is nothing but 0. Next, if n is equal to 1, x is equal to 1 square. 1 square is nothing but 1. Next, if n is equal to 2, x is equal to 2 square, which is nothing but 4. If n is equal to 3, x is equal to 3 square, which is nothing but 9. Alright. Next, if n is equal to 4, x is equal to 4 square, which is nothing but 16. Very good. So here we have the set A, which is 0, 1, 4, 9 and 16. A is there. Let us extract B also. B. Here B is in the B. What is the function given? X is equal to 3n plus 1. 3n plus 1, and the value of n is between minus 3 to 2. Minus 3 to 2, in the sense minus 3 also is supposed to be included, because it is minus 3 or equal to, n is greater than or equal to minus 3, lesser than or equal to 2. So from minus 3 to 2, value of n is n is equal to minus 3, minus 2, minus 1, 0, 1, 2, 0, 1, 2, right. If n is equal to minus 3, x is equal to 3 into, in the place of n we have to write minus 3. 3 into minus 3 plus 1. 3 into minus 3. Minus 9 plus 1. Minus 9 plus 1 is minus 8. Next, if n is equal to minus 2, x is equal to 3 into minus 2 plus 1. In the place of n I am writing minus 2. 3 into minus 2 is minus 6 plus 1. Minus 6 plus 1, minus 5. Next, if n is equal to minus 1, x is equal to 3 into minus 1 plus 1. 3 into minus 1, minus 3 plus 1, which is minus 2. Minus 3 plus 1, minus 2. Next, if n is equal to 0, x is equal to 3 into 0 plus 1. 3 into 0 is 0 plus 1, which is 1. Next, how many more are there? 1 and 2. If n is equal to 1, x is equal to 3 into 1 plus 1. 3 1 is 3 plus 1. 3 plus 1, 4. Last, if n is equal to 2, x is equal to 3 into 2 plus 1. 3 2's 6 plus 1, which is nothing but 7. Here we have set B. B is equal to minus 8, minus 5, minus 2, 1, 4, 7. Here we have A and B. We have to find number of terms in B minus A. Let us first find B minus A. Then we will find the number of terms in it. N of B, number of terms in B. We can directly calculate here. Number of terms in A intersection B. Let us first do A intersection B and then find the number of terms in it. B minus A. B minus A. What is B? Minus 8, minus 5, minus 2, 1, 4, 7, minus A. 0, 1, 4, 9, 16. We have to, while doing minus, we have to cancel out the similar terms in the first set. Similar terms in the first set. 1 and 4. 1 and 4 are gone. B minus A. What is remain? Minus 8, minus 5, minus 2 and 7. Number of terms. N of B minus A. Number of terms in B minus A. How many terms are there? 4 terms are there. Let's just complete it. Number of terms in B. Here only we'll write. Number of terms in B. How many terms are there? 6 terms are there. Next, A intersection B we have to do and then find the number of terms in it. A intersection B. What is A? 0. No. 0. We have to write the sets once and then find the common terms in it. While practicing you can do that, but however I have to upload this on YouTube. That's why I have to write the entire part. 0, 1, 4, 9, 16 intersection B. What is B? Minus 8, minus 5, minus 2, 1, 4, 7. A intersection B. 1, 4. 3 is not there. Number of terms in A intersection B. How many terms are there? 2 terms are there. Right. Sure. Let us substitute here LHS. LHS is number of terms in B minus A. Number of terms in B minus A. 4. RHS. Number of terms in B. Number of terms in B minus number of terms in A intersection B. Number of terms in B. How many terms are there in B? 6. Minus number of terms in A intersection B. 2. 6 minus 2. 4. LHS equal to RHS. Hence proof. Yes. Here. We have another question here. A is a set wherein x is a variable such that x is equal to log n. N is equal to 10 power m. M is less than 6. M belongs to n. Set builder form to roster form we have to convert, and then here B is a set wherein x is a variable such that x is equal to minus 5 less than x less than 5. This is pretty easy. We have to write the values from minus 5 to plus 5. X is greater than minus 5 to plus 5. Minus 5 is not supposed to be included because there is no equal to sign. If it is equal to, then we would have included minus 5 and plus 5 as well. My equal to sign is not there, which means greater than minus 5. Greater than minus 5 is minus 4. It starts from minus 4 to plus 4. B is pretty easy. A is complicated here. See, log n. Log n. This is actually the combination of question from real numbers and sets. One of the formula from real numbers will be utilized here. I'll explain you. Log n. N value is 10 power m. Here we have to substitute in the place of n, right? 10 power m. M is less than 6. Less than 6 in the sense till 5. Till 5 we have to take. But where do we have to start from? Natural number, which means 1. 1 to 5. First, let us break down it a little. A is a set wherein x is equal to log n. Value of n is equal to 10 power m. And m is equal to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. In the place of n, I'll write 10m. In the place of n, x is equal to log n is nothing but 10 power m. 10 power m. What's the value of m? 1 to 5. Right. First, if m is equal to 1, if m is equal to 1, which implies x is equal to log 10 power 1. Log 10 power 1. Log 10 power 1 in the sense 1 log 10. One formula in the real numbers we have discussed about this formula. Log x power n is equal to n log x. Whatsoever is there in the power of x, we have to bring that in front, right? So 1 will come here, it will become 1 into log 10. Now what's the value of log 10? Log 10 value is 1. 1 into 1. 1 into 1 is nothing but 1. Next, if m is equal to 2, x is equal to log 10 power 2. 10 power 2. With the help of that formula, 2 will come before. 2 into log 10. Log 10 value is again 1. 2 into 1. 2 into 1 is nothing but 2. Next, if m is equal to 3, x is equal to log 10 power 3, 10 cube, 3 log 10, 3 log 10, which is nothing but 3 into 1, which is 3. Next, if m is equal to 4, m is equal to 4, x is equal to log 10 power 4, 4 log 10, 4 log 10, 4 into 1, 4. Last, if m is equal to 5, if m is equal to 5, yeah, less than 6, no? Less than 6 in the sense, still 5 you have to take. Don't get confused. X is equal to log 10 to the power 5. 10 to the power 5 is nothing but 5 log 10. 5 log 10. 5 into 1. 5 1 is 5. So here we have the set A, which is nothing but 1, 2, 3, 4, 5. Set B is directly we can write x value is minus 5 to 5. Minus 5 and 5 are not supposed to be included because equal to sign is not there. I have already told you couple of times. So it is minus 5 greater than minus 5 ante minus 4 से लेके 4 तक. Minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Clear? That is set A. Here we have set B. Now he asked us to find n of, sorry, A intersection B, A minus B, B minus A. I have already told you how to do minus in the previous videos. That is not a problem. So in certain questions it might also ask you to draw the Venn diagram along with this, which you have to anyways do it. Okay, I am not doing that part. You have to complete it from here. Clear? Shall we move on to the next problem? Copy this down, fatapat. Here we have another question. One more question from set. P and Q are sets. In the set builder form, we have to convert into roster. X is a composite number less than 15. Composite numbers are the numbers which goes in more than one table, like 4, 6, 8, 4, 6, 8. Yes. So P is equal to 4. Let us directly write the set. P is equal to 4, 6, 8, 9, 10, 12, 14, 15. Less than or equal to 15 in the sense you have to include 15 as well. Right? Next. Q. Q is 3n. Value of Q, it's a function and it is 3n. N is less than 10. N is less than 10, it won't be Z, it will be capital M, natural number, because Z is, it will go till minus values, which is minus infinity, that won't be true. N is equal to 1 to 10. Less than 10, what does this less than 10 indicate? The value is till 9. N belongs to capital M indicates it starts from 1 to 9. Next, if 1 to 9, yes. 1 to 9. If n is equal to 1, x is equal to 3 into 1, which is 3. If n is equal to 2, x is equal to 3 into 2, 6. Yes, 3 table. 3 9 36. Till 36 you have to write, but in paper you have to represent when you know. X is equal to 3 into 3. You know, I know, but how can examiner know? So n is equal to 3. Next, if n is equal to 4, x is equal to 3 into 4, 3 4s 12. If n is equal to 5, x is equal to 3 into 5, 3 5s 15. If n is equal to 6, x is equal to 3 into 6. 3 6 are 18. If n is equal to 7, x is equal to 3 into 7. 3 7 is 21. If n is equal to 8, x is equal to 3 into 8. 3 8 24. If n is equal to 9, x is equal to 3 into 9 27. And we shouldn't take 10 less than 10 till 9. Right here we have the set q. Q is nothing but 3 6 9 3 6 9 12 15
18, 21,
24 27. This is the set P where we have set Q. We have to find the value of P intersection Q, P minus Q, Q minus P, and also draw the Venn diagrams for the same. Right? Will you be able to do that, right?
Yes, sir.
Two more questions related to Venn diagrams. A Venn diagram is given one in the first set 1 3 and 5 2 4 is there here and 6 8. We have to find the value of A union B, A intersection B, A minus B, B minus A from the given sets. A union B in the sense will include all the values. This 9 and 10, this is given just to confuse you. Need not to worry about that. A union B. Union in the sense will conclude, will take all the values in the set A, in B and the common elements as well. A union B is equal to 1, 2, 3, 4, 5. Right? Is that it? 1, 2, 3, 4, 5 and 6 and 8 as well. Because union in the sense all of the values, common terms will be written once and whatever is there in the first set and in the second set that has to be written. So 6 and 8. This is A union B. Next step. A intersection B. A intersection B in the sense will take only the values which are common. Only the values which are common. What are the common values in both the sets?
2, 4.
2, 4. So 2 and 4 is the answer for intersection. A minus B. A minus B. What is there in the first set? 1, 3, 5. 1, 3, 5. Next step. B minus A. 6, 8. That's all.
Sir, first we have to write a set A elements.
No, not required. That way also we can do directly. We can set first we'll write set A, then we'll write set B, then find A union B intersection. That is also fine, but then this is the shortest method. If you're doing that way, that is also fine, not a problem here. Now A minus B is given, B minus A is given, A intersection B is given. We have to find the set A and set B. We will draw the Venn diagram in order to find the value of this. Right. A minus B, 2, 3. B minus A, 1, 6, 8. A intersection B, 4, 5. Right? This is A, this is B. In the set A, what is set A? In set A, what are the values? 2, 3, 4 and 5. 2, 3, 4, 5. What is there in set B? 1, 4, 5, 6, 8.
Sir, it did not mention in question we have to draw Venn diagram.
No, he did not mention in the question. In order to find the sets when minus and combination is given, we'll use Venn diagram in these cases. So these are basically main questions which we have solved so far in the 3 videos. Let me know in the comment section if you understand this or if you have any doubts. We can clarify in the following video. Till then, have a nice day. Take care. Bye bye.